Hello, this video is for IXL Activity A1.J.10. It is titled Solve Linear Equations, and these are indeed word problems. The 3-character code for this activity is Uniform Foxtrot Golf. So our first question is, Camille earns $13 for each hour of dog walking. After a total of 2 hours of walking dogs, how much money will Camille have earned? Well, if we think about these are linear equations. So if we think back to linear equations, we can represent a linear equation as y equals mx plus b. And we'll talk about what each of these variables represent. First of all, the m is our slope. And whenever we talk about the slope, we're also talking about the rate. So we're talking about a rate of speed or a rate of pay, or a rate of doing something like cooking 20 cookies per hour. That 20 per hour would be our rate. So we're looking to find our rate and put it in the place of m. Our b here, the value of b, this is a starting amount. So if we're starting with something, I guess I'll put an ing on there, starting amount. Can't seem to spell and talk, M-O-U-N-T. There we go. So B represents our starting amount. So if they tell us that Susie can bake 20 cookies per hour and she's already baked 50 cookies, how many cookies will she have after 6 hours? That type of thing. Well, 50 cookies is what she has already starting off with, so we would have a starting amount. So if we have a starting amount, we're going to put it in the place of B. Our value of X, this is our input. So we're going to create a function, or we're going to create an equation, which is going to be a function. And then we're going to have an input, and we can put in the input and then do the calculation if we know the slope and the starting amount. And then after that, that's going to produce for us an output. So output there. So the m is our slope, or the rate of at which we're doing something. Our b is our starting amount, and our input is an x value, and our output is a y value. So if you've had this before, this type of discussion before, you're kind of familiar with that. And if not, we'll go ahead and we'll work on that some. So I'm going to be referring to this concept of a slope, a starting amount, an input, and an output as we go through this. So let's go ahead and apply this to Camille. She earns $13 for each hour of dog walking. Well, that's $13 per hour, right? So this is going to be our rate right here. So whenever we have something per something, usually that's going to be our rate. So $13 per hour. After a total of 2 hours of walking dogs, how much money will Camille have earned? Well, we understand that dollars is going to be a function of how many hours that we walk the dog, right? So in this case, the number of hours is going to be our input right here. This is our input for our, just like the X. The money is going to be our output. It's what's being determined by the input. Our rate is going to be 13. And we don't have a starting amount. So I guess technically we could go ahead and put 0 on here. This is our starting amount here. I'll just put SA for starting amount. And this here, $13 is going to be our rate, or also, if you want to call it, our slope. So we have dollars equals 13H. And what do they give us? They say after a total of 2 hours. So this is going to be our input. So we're going to go ahead and substitute in the value of 2 for hours, because that's our input. And in the end, we'll see that the amount of money she has is 13 times 2, which is going to be 26. Therefore, she would have $26 after 2 hours of walking dogs. So each of these problems, we're going to approach that with the concept of what is a rate, what is our starting amount, what's going to be the input, and what's going to be the output. On our next problem, a corporate team building event costs $4 plus an additional $1 per attendee. If there are 31 attendees, how much will the corporate team building event cost? So we recognize that cost is going to be a function of how much per attendee. Well, this is our rate right here, $1 per attendee. So this is going to be our rate. and the number of attendees is what produces our dollars, right? So the number of attendees is going to produce the amount of dollars, and how much is it per attendee? That is to say our rate. It's going to be 1. I'm going to go ahead. I really wouldn't have to put the 1 in there, but I'm going to go ahead and put that there for now just so we recognize that that's our rate. And do we have a starting amount? Well, a corporate team building event costs $4 plus $1 per attendee. So we do have a starting amount. So our starting amount is 4. This is going to be our starting amount here. Now let's see what they give us. We're going to have an input here of 31 attendees. So for where we see the A for our input here, we're going to plug in 31, and that's going to give us our output here, which is dollars. So number of attendees determines the number of dollars. The dollars is a function of the number of attendees. So let's go ahead and do that. Dollars is going to equal 1 times A is going to be A and plus 4. Now let's subtract 4 from each side. And in this, I need to substitute. What am I doing? Silly me. I got to substitute in the number of attendees. So 1 equals, our dollars is going to equal 1 times number of attendees. We're going to put in 31, and then we're going to add 4. Yeah, it's going to say that just doesn't sound right. So 1 times 31 is 31. Let's bring down our plus 4, and now we can go ahead and add the 31 and the 4 together to get 35, and we see that our answer is $35 for the corporate team building event. On the next one, Janice has already baked 11 pies, so this is our starting amount, right? And she can bake 2 pies with each additional cup of sugar. So this is our rate right here. We got a rate right there. 2 pies per cup of sugar. So it's 2 times S. 2 pies for every cup of sugar. How many additional cups of sugar does Janice need in order to bake a total of 43 pies? So the amount of sugar determines the amount of pies. So we have sugar is our input, pies is our output, and we see our rate up here is going to be 2, and we have a starting amount up here of 11 plus 11. So now we need to see, what are they giving us? Are they giving us an input for us to determine an output, or do we have an output and we're going to determine the input? Because we could go backwards as well. We could have the output and find out what the input was. So they want to know for a total of 43 pies. So this is actually an output here because it's the number of pies is determined by the amount of sugar. So we're going to substitute in 43 here. And now we're going to bring down our 2S plus 11. And now we're going to solve for S. So let's go ahead and subtract 11 from each side. Minus 11. So over here, 43, 33, 32, right? 32 equals 2S. Those 11s canceled each other. And now let's go ahead and divide by 2. That's going to leave us S on the right. And 32 divided by 2 is going to be what? 16, right? And so it's going to be, she's going to need 16 additional cups of sugar. When ringing up a customer, a cashier needs 6 seconds to process a payment, as well as 1 second to scan each item being purchased. So 1 second per item. 1 second per item. So I is going to be our, do I want to do it that way? Let's see. Yeah, I guess I'm thinking I looks like the number 1. I really hate using the letter I as a variable, but we'll go ahead and do it. So 1 second per item. And do we have a starting amount? Well, it takes 6 seconds to process the payment. So we're going to have a starting amount because no matter how many items we have the 6 seconds that we're going to take to process the payment. So this is going to be our starting amount. This is going to be our rate here. I is going to represent the number of items. So if it takes 24 seconds to ring up a customer, how many items are produced? So we want to know how many seconds, right? Seconds to do this is a function of the number of items. And we know that it's 1 second per item. And I'll put that in parentheses, kind of keep it separate from the I. And we do have a starting amount, in this case, of 6. Now they want to know if it takes 24 seconds, how many items are there? So this is actually our output right here. Output. Keep wanting to just abbreviate it, OP. And so we have an input of seconds, right? Seconds is our input. Make sure we get everything labeled there. Now, they're giving us the output. So we're going to put in 24 right here. Now let's go ahead and do 1 times I is I, and plus 6. Now let's subtract 6 from each side. And we end up with, what, 18 equals I, so it's 18 items. And again, each time we're just looking for, do we have a starting amount? What is our rate? What is the input? What is the output? We know what the input is, and we know what the output is because we have to consider one causes the other. In this case, the X causes the Y. Whenever I say the X causes the Y, let me go back to that first page there. The X determines the value of Y, right? X is the independent variable, Y is the dependent. Y depends upon whatever we put in for X. So we'll go ahead and look at the next one. Chloe has already written 18 pages. Oh, there's our starting amount, what we have at the beginning. And she expects to write 2 pages for every additional hour. So this is going to be our rate, 2 per hour, right? Rate. Our rate is going to be 2, and our number of hours is going to be our input. And so we'll just call our rate is 2H, right? 2 per hour. After spending 2 hours of writing this week, how many pages will Chloe have written in total? So the number of hours determines the number of pages. The number of pages we have depends upon how many hours that Chloe writes. We do have a starting amount of 18. So we're going to start with 18. And our rate, remember, is 2 pages every hour. Now, what do they give us? They give us an input after spending 2 hours. So we're going to substitute in 2 for H here. So P equals 2 times 2, just substituting in the input that they give us, plus 18. Now let's go ahead, multiply 2 times 2 is 4, plus 18. And now we can go ahead and add 4 and 18 together to get 22. So she'll have 22 pages after 2 hours. Kendrick walks 2 kilometers during each trip to school. After 2 trips, how many kilometers will Kendrick have walked? So 2 kilometers during each trip. So this is 2, and we'll call trips the input. The number of trips determines the number of kilometers. And our rate is 2, so it's going to be 2t. I don't like that t. It doesn't look like my normal t. It looks like a plus sign. There we go. So trips is our input, and the number of kilometers is going to be our output. So trips determines kilometers. Do we have a starting amount? Indeed, we do not. So at this rate, we just have k equals 2t. So after 2 trips, so they're giving us an input. So we're going to substitute in for t. We're going to substitute the value of 2. And now we just have 2 times 2 is 4. The number of kilometers he's walked is 4. Now, many people would probably be able to figure that out without setting all that up and understanding all that. If I say he walks 2 kilometers for each trip, if he takes 2 trips, how many kilometers did he walk? 4. So let's look at the next one. I guess her name is Marina. She set her watch 8 seconds behind, and it falls behind another 2 seconds every day. So the number of days, this is a rate, 2 per day, 2 per day. So day is our input. And we do have a starting amount, and that is 8. How far behind is Marina's watch if she last set it 44 days ago? So the number of seconds that the watch is behind is a function of how many days it's been since she set it. Our rate is 2 seconds per day, and we have a starting amount of 8. They give us the number of days, so this is an input, right? And our output is seconds, right? So let's go ahead and S equals 2 times the number of days, in this case is 44, and plus 8. Now we can go ahead and multiply 2 times 44 to get 88. Now let's bring down our plus 8. And then finally we can do 88 plus 8, which is going to be what, 96? So her watch is 96 seconds behind. While working at the drugstore, Cora earns $11.09 per hour. How many hours will it take for Cora to earn $33.27? So the amount of money she makes is a function of how many hours she works. And what is our rate? We need to know what our rate is. Well, our rate is $11.09 per hour. So this here is indeed our rate. The number of hours is our input. And I can't spell input, forgot the N, I-N-P-U-T. And our output is money, right? So number of dollars equals 11.09H. How many hours will it take her to earn $33.27? So they're actually giving us an output here. And so we're going to plug in the output that they give us, 33.27 equals 11.09 H. Now we need to solve for H, so let's divide both sides by 1109. What we do to one side, we're going to do to the other. And I'm going to use a calculator for that. So 33.27 divided by 11.09, and that's going to be 3. So the 1109s cancel each other there. We end up with just H, and over here 33.27 divided by 11.09 is 3. So it's going to be 3 hours that she must work in order to earn $33.27. A members only speaker series allows people to join for $10.23 and then pay $1.60 for every event that they attend. Sounds like a rate, doesn't it? $1.60 for each event. So we have $1.60 for each event, where our event is the input and the amount of money is our output, right? So the amount of money that we spend is a function of how many events that we attend. And we do have a starting amount right here, right? We have to pay $10.23 just to join the club. And so we're going to have a starting amount of $10.23. And remember, our rate over here is $1.60, so we'll just put 1.6. Now, let's see what they give us. They give us an input, right? The number of events. So we're going to, in the place of E over here for the input, we're going to go ahead and put that value there. So the amount of money is going to be equal to 1.6. And then for E, we're going to put in 22. And then we have to add our $10.23. So next step is to go ahead and multiply the 1.6 times 22. And that's going to be 35.2. And we're going to add to that 10.23. So let's go ahead and do that now. Add to that plus 10.23. And that's going to give us a total of $45.43. So our cost is $45.43. All right, final question here is Caleb has already run 13.99 miles on his own. So this sounds like a starting amount. He's already. So this is, whenever you see the word already, that's definitely a starting amount. And he expects to run 1 mile per each track practice. That sounds like a rate, something per something, right? So we're going to have 1 mile per each practice, and we'll use P for practices. So this is going to be our input here. Input. And we're talking about miles. So the number of miles ran is a function of how many practices that he goes to. And our rate for each practice looks like he runs 1 per practice. And we do have a starting amount of plus 13.99. Now we're all set up. Let's see, do they give us an input or do they give us an output? How many track practices would it take for Caleb to run 29.99 miles? So they're giving us an output. So let's go ahead and plug in that 29.99 equals 1 times P is just P plus 13.99. Now, next thing we need to do is to go ahead and subtract 13.99 from each side. What we do to one side, we're going to do to the other. It's going to work out real nicely. And 13.99 is going to cancel each other, leaving us just P on the right. And then we're going to have 9 minus 9 is 0, 0. And 9 minus 3 is 6. And 2 minus 1 is 1. So it is indeed 16 practices. All right. So those are all of my examples for IXL Activity A1.J.10 solving linear equations. And they are indeed, again, word problems. And good luck with your activity.